Hello everyone, my name is Lokesh Joshi. In this video, we are going to understand about the topic of complex numbers. And I will take 4 to 5 videos to cover this whole topic, in which we will solve some problems as well. Now, before wasting any time, let me give you the introduction about the topics which we will cover in this chapter. First of all, we will learn about the iota. And iota is the very basic unit of this chapter. Okay, and after that we will know actually what is complex numbers, which is denoted by Z. After that we will do about equality of complex numbers. Like suppose we have any two complex numbers, let us say Z1 and Z2. So in which case we will say is Z1 is equal to Z2. Okay. Now after that we will go through about the power of iota. As iota is done here, then about powers of iota means like iota square, iota cube and so on. After that we will cover about the algebra of complex numbers, in which we will discuss about addition, subtraction, multiplication and division of complex numbers. Now the main point is that like in the many videos or most of the educators tell this topic algebra of complex numbers before power of iota, but I will take power of iota first. After that we will discuss algebra of complex numbers, because we will use power of iota in some concept of multiplications. Okay, now after that we will do Argand plane. Basically, it is the plane in which we will represent our complex numbers. And after that, we will do our last topic, which is modulus and conjugate of complex numbers. And we will also do graphical representation of conjugate and modulus in the Argand plane. Okay, so now let us start our topic with the iota. Iota is represented by small I. So basically, if I write directly, iota is equal to under root minus 1. Okay, but this iota is came from. Okay, so let me give you the idea behind it. Idea behind origin of iota or I. Okay, so before, whenever we have done quadratic equations in the class 10, we have done that if we have any equation x square minus 1 is equal to 0, then for solving this one we will do x square is equal to 1, which implies x is equal to plus minus 1. Okay, this is our solution for the equation when we have x square minus 1 is equal to 0. But if we have x square plus 1 is equal to 0, which means x square is equal to minus 1. And after that we will get x is equal to under root minus 1. So this is our problem, how we can solve this type of numbers. Okay, so for simplicity or to get solution of such type of problems, we introduced the term iota, which is known as iota is equal to under root minus 1. So for this equation x square plus 1 is equal to 0, we have solution x is equal to plus minus iota. Okay, this is the basic idea behind the origin of iota. So as of now it is clear where iota comes from, and iota is equal to under root minus 1. Now we are able to understand about the concept of complex numbers. Okay, so what is complex numbers? All the numbers of the form a plus eta b, where a and b are real numbers and eta is equal to under root minus 1, as we have done before, are known as complex numbers. And we denote complex numbers by z. Okay, this is small z. So definition is that all the numbers of the form a plus eta b, in which a and b are real numbers and eta is equal to under root minus 1, are known as complex numbers. I am giving the example. Suppose z is equal to 2 plus 3 eta, in which 2 and 3 both are real number and eta is equal to under root minus 1. Okay, and if we write generally any complex number which is a plus eta b, it has two parts. One is this one a and another one is b. So if we define properly a and b, then they are known as real and imaginary parts of complex numbers. So I am writing this one. Real part of complex number z is equal to a plus eta b is a, in which we don't have eta. If eta is present as the coefficient, then this one is imaginary part. Without eta, it is our real part. So for complex number z is equal to a plus eta b, we have its real part is a, which is denoted by real part of z is equal to a. This is our representation. Now imaginary part. Imaginary part of complex number z is equal to a plus eta b. So for this one we will also do the same thing, but in that case we have to take the number which is the coefficient of eta, and in this case we have b, which is coefficient of eta. So imaginary part is equal to b, and it is denoted by imaginary part of z is equal to b. Okay, so now we have done about the concept of complex numbers, and there are two parts in complex numbers. One is real part and another one is imaginary part. Now I am giving you a question to solve so that this concept will be strong. Write imaginary and real part of z is equal to 6 plus 3 eta. Okay, you can pause the video and find the answer. Now I am solving this one. So for writing real part of z, we will write re and bracket z. If we compare these two with r is equal to a plus eta b, then we get the number a is equal to 6, this one, which means the part which has no eta is 6, so it will be equal to real part. Now imaginary part of z, the number, real number in the z, which is the coefficient of eta, is known as imaginary part of z, and this one is 3 written there. So imaginary part of z is equal to 3. Okay, so this is about the topic of complex number and imaginary and real part. Now after that we will do about the powers of eta. Let me write again. Eta is equal to under root minus 1, or we can write eta is equal to minus 1 to power 1 by 2. Okay, now in this topic, powers of eta, we will go as eta square, eta cube, eta to power 4, up to ita's power n. Okay, and after solving all this one, we will give the general and the simple representation about the ita's power n, how we can simplify this one. Okay, and we will do some problems as well. So first of all, eta square will be eta multiply eta, which means under root minus 1 under root minus 1, which means minus 1 square under root, but we will take eta square is equal to minus 1, as it is the square of minus 1 and whole under root. Okay, so eta square is equal to minus 1. Now eta cube, we can write eta cube is equal to eta multiply eta square. Is it correct or not? And after that we can write eta multiply. What is eta square? Written there is eta square, and from the first one we can find eta square is equal to minus 1. So we will write eta multiply minus 1 in place of eta square, which means eta cube is equal to minus eta. Okay, now eta power 4, we can write it as eta square multiply eta square, which means, and eta square from the first line is equal to minus 1. So we can write it is minus 1 multiply minus 1, and minus minus is plus, 1 into 1 is 1, so we get eta power 4 is equal to 1. Okay, let me write all the 4 things in the proper way. Eta square is equal to minus 1, eta cube is equal to minus eta, eta power 4 is equal to 1. Okay, you have to remember these 3 things. After that we can solve our more powers of eta in very simplified way. Now using this one we will do eta's power 5, which is equal to eta multiply eta power 4. Eta power 4 is equal to 1 from this line, so we can write eta multiply 1, which is equal to eta. Okay, so if we have eta, then eta square is equal to minus 1, eta cube is equal to minus eta, eta 4 is equal to 1, and if we do power 5, then it will become eta again. Okay, but suppose we get the question in which we have to calculate suppose ita's power 20. So for this one, we will not do ita multiply ita 20 times. Okay. It is not the perfect way, but we have done this thing, so we will generate some general rule, and using that we will find our answer. Okay, so using all this one, you can write it as a note that ita's power 4k is equal to 1, where k is any integer. And more specifically, k is positive integer. Okay, so whenever we have ita's power 4k, it will be equal to 1, where k is any positive integer. Now solving this question, this one. We have to calculate ita's power 20. Can we write ita power 20 is equal to ita power 4 and whole power 5. We have break down the power 20 into 4 and 5, and ita power 4 is equal to 1 and 1 to power 5 is equal to 1. So we can say ita's power 20 is equal to 1. Okay, this is our answer. Now we will do one more question, and before that I am giving you the general rule. Ita's power 4k plus r is equal to ita's power r, where k is any positive integer and r is equal to any one of the following 0, 1, 2, 3, which means if we have ita's power 4k plus 1, then it will be equal to ita power r, and r is equal to 1 in this case, so it will be equal to ita. And ita power 4k plus 2 is equal to ita square. Ita power 4k plus 3 is equal to ita cube, and ita power 4k we have done already, it is equal to 1. Okay, that's the thing. You have to remember this one. Now I am giving you one question. Simplify ita power 17. This is the first part, and second ita power 23. You can pause the video. Now I am solving this. You can verify your answer. Now first one, in which we have to calculate ita power 17. Can we write 17 as 16 plus 1? So it will be equal to ita power 16 plus 1, which is ita power 4 multiply 4 plus 1. Now is this one, ita power 4 multiply 4 plus 1, is similar to this first one, ita power 4k plus 1, where k is integer and here k is equal to 4. So without solving, we can directly write is equal to ita power 1, which is equal to ita. You can verify is this is your answer or different. So it will be equal to ita. Now second one, eta power 23. We can write it as eta power 20 plus 3, which is eta power 4 multiply 5 plus 3. It is also of the form eta power 4k plus r, where r is 3, and we can match this one with the third one, this eta power 4k plus 3. We can directly write it is equal to eta cube. And what is eta cube? We have done before. So eta cube is equal to minus of eta. It is given there, you can check. Eta cube is equal to minus of eta. So we can write is equal to minus of eta. So for second one, our answer is minus of eta, and first one is eta. Okay, I hope all this concept we have covered are clear to you. Now it's all for this video, and in upcoming videos we will do more concept. Okay, today we have done the about eta and what is complex numbers. This one we have to do equality of complex number. We will do this one in our next video. Power of eta is also done. Okay, now 5, 6, 7 and 3 topic. All these 4 topics are remaining. We will do them in the upcoming videos. Okay, so thank you all.